I think it's fair to say that we really are at an inflection point right now. We're clearly making a transition. Pre-2007, we had feature phones. Between 2007 and now-ish, right? We've had smartphones. And in the last few years, clearly we're making a transition into a new category, and that's an AI phone. And I feel that Pixel and Tensor have really been at the front of that pack. We made that turn into that inflection point early.
Welcome to the Made by Google podcast, where we meet the people who work on the Google products you love. Here's your host, Rachid Finge.
The Pixel 10 smartphones have some amazing, groundbreaking AI features, like Live Translate, Magic Queue, and ProRes Zoom on the Pro phones. And what ties them all together is the Tensor G5 chip in the Pixel 10 phones. Talking to us today about Tensor G5 is Jessie C., the Group Product Manager for our Silicon teams.
This is the Made by Google podcast.
Jessie, welcome back to the Made by Google podcast. It is great to have you and very special as you were our second guest ever.
Oh,
Back
wow.
then, working on security and Tensor. So what changed for you in the meantime?
Oh, just working on more Tensor stuff. So it expanded a bit. So now not just only working on security, but working on the whole of the chipset, which is a great challenge and very exciting too. I can't believe I was your second guest. That's amazing. What season are you on now?
This is season 8, so we've been at it for a while. And as do you when it comes to silicon. What got you into silicon in the first place?
Oh, that's a great question. I have been into hardware and building things and mechanical things since I was quite young. So I remember spending time in the garage with my dad, taking things apart, putting them back together. He was a natural engineer, liked to build things himself, and he was really into audiovisual equipment too from a young age. So it was sort of just around our house at all times. I think one of the big turning points for me was when I took physics in high school. And I recall really distinctly, it was one of the first times that I had to work really hard in school. Everything was fairly easy. I loved math, I loved English and science and all of those subjects. When I got to physics, I was challenged for maybe one of the first times in my academic career. And from physics, I remember within the physics class having our first unit on electricity and magnetism and getting to work with a breadboard, which is a very simple circuit board. You plug these manual leaded resistors into and getting, LEDs to light up, and just thinking that was incredibly exciting and really fun and logical. And it harkened back to my days in the garage of taking things apart, putting them back together. So, I think that's what got me into electronics. And now at Google, working on AI processors for Pixel phones.
So, engineering, and that brought you and us today to Tensor G5, the chip that powers everything on the Pixel 10 series smartphone. So, we'll talk in depth about G5, but let's talk about the Tensor part first. What is Tensor? You could say it's a system on a chip, but then that still doesn't mean a lot to many people. So, can you explain what is it, Tensor?
Absolutely. So the way to think about it is that Tensor is the brains of the Pixel phone. Basically, everything that runs on your phone, all the operating system software, the AI experiences, the photography, when you're taking photos and editing those photos, all of that runs on Tensor, which is the application processor, also known as a system on a chip. We say system on a chip, or SoC for short, because it is one chip that encompasses many, many different systems. In certain computer architectures, say like on your laptop, especially generations ago, you'd have lots of individual chips for different functions, like a GPU, a CPU. In a system on a chip, we pull all of those blocks together into one die, one single piece of silicon that has all of those inside of them.
So why bother making Tensor? I mean, there are SoCs all over. You could get them from maybe another manufacturer. Mm-hmm. Why did we start the whole Tensor project in the first place a few years ago?
That's a great question. We started the Tensor program because we wanted to bring the best of Google research to life on Pixel devices. And we felt that the best way to do that was really to have control over the entire technology stack. So I'm sure you've heard it, and Made by Google, Rick Osterloh, who's our GM, talk about our full tech stack. So Google's in a really unique position because we have like all these components across the entire technology stack, everything from these very advanced models that run on cloud TPUs, the cloud TPU hardware, the server-side hardware that runs these models. We have an operating system, the world's largest, operating system that's ever existed with Android. We have device hardware and Pixel, and then very importantly now, we have that critical component, the foundation of the technology stack, which is Tensor Silicon. So this full tech stack solution is what is allowing us to transition really successfully into what we're calling the Gemini era. So it's allowing us to bring innovations like Gemini, large language model, to users. And so Tensor is like a very critical piece of that journey. It's the foundation of that tech stack. That's been our mission from the beginning with Tensor. If we think about, so Tensor G5 is our 5th birthday, right? It's our 5th generation. And just to put in perspective how quickly, the progress of AI innovation since then, we can look at things like, say, parameter count on models. So these machine learning models that are running on the phone have become exponentially more complex. So I'll give you a really concrete example. The zoom model that we use in the camera. So when you're in live preview, you zoom in on an image. The state of the art for the machine learning model that was handling zoom back a few years ago was around tens of thousands of parameters, like back in 2021. Now, last year, that same in-camera zoom model was a few million parameters. And now this year, with Tensor G5 on the Pixel 10 in the ProRes Zoom feature, which, Rachid, I'm sure you've got a chance to check out by now. Incredible, right? The intricate resolution we're able to get in ProRes Zoom. The machine learning model that's running in the camera for ProRes Zoom is nearly 1 billion parameters. So in just, for 4 or 5 years, we've gone from tens of thousands to a few million to nearly 1 billion parameters running completely on device. So this kind of exponential curve that we're experiencing. It's difficult to keep pace with, but we're actually pushing that forward with Tensor Silicon. So that's something we're really excited about and is really central to the mission.
So obviously every Tensor chip gets better and better year over year, but for Tensor G5 compared to G4, we called it groundbreaking. We said it was sort of the biggest leap forward in Tensor's history. So what makes us say that? What are the changes between G4 and G5 this year?
Yes, indeed. Tensor G5 is our biggest upgrade yet. And it's a really a milestone for us because we've been in a multi-year journey really since 2021. Really, when we launched our first chip, we began thinking about this transition we were going to make with Tensor G5. We have far deeper customization in the chip, for everything from architecture through to the way we're manufacturing. And that's allowed us to really see leaps in many areas of performance, AI innovation, camera quality, and more. So to give you a couple, concrete proof points here, say take our TPU, the tensor processing unit within the tensor chip. We're putting up 60% uplift for compute, up to 60% more compute just in the TPU core, just versus last year.
And a TPU is what does all the AI stuff, right?
It processes machine learning, things like Gemini Nano, things like that, nearly 1 billion parameter ProRes Zoom model, camera model I mentioned, features like ADME, many more. So a lot of the machine learning processing is very custom built for Google machine learning and AI on device. So that core alone has 60%, up to 60% more compute. Then take the CPU, the central processing unit, which does a lot of general purpose computing. People will be probably most familiar with the CPU. And that subsystem has 34% on average performance uplift. Again, just versus last year. That's a very large single year gain. And then we have upgrades in some of our custom IPs as well. One that I'm really excited about, and maybe we can chat about it a little bit later because I want to make sure I hit all the high points here at the top. But another one we're really excited about is the ISP, or the image signal processor. As the image signal processor helps process your camera photos and videos. And really big upgrade there for us this year. Fully custom. We've customized the pipeline in a lot of different ways to bring far higher quality and both to stills and to still photos and to videos. And then upgrades in our security IP, really upgrades across the totality of the chip. We've made upgrades not only in our IPs, but in the infrastructure and, as I said, the way we're manufacturing the chip. And another most exciting upgrade for us this year is our transition to the leading TSMC 3-nanometer process node.
Yes, I wanted to get through that because everyone's talking about it, and I bet nobody actually knows what they're talking about because I guess 3 nanometers is better than a higher number of nanometers. Why?
Yes. So process node, I know it gets tossed around a lot, but it is highly technical and kind of a niche thing. So I thought I'd use maybe some analogy to help explain it for those that are not living and breathing this stuff every day. So Rachid, you have kids, right?
I do, yes.
Okay. How old are your kids?
1 and 4.
Okay, excellent. 1 and 4. I have a just turned 8-year-old and a 10-year-old. So I'm sure between the both of us, we have a lot of Legos and other blocks around the house. Yes.
Yes.
Okay.
You can probably see them here in the background.
Oh yeah, you got some Legos. There's always Legos.
Yes,
in every part. It's like glitter in the house of people with young kids. So your 1 and 4-year-old, right, are probably playing with something like a Duplo block, something that looks a little bit like this, right? Like a large block. So these are the Duplo blocks that Lego makes specially for toddlers. So they're a larger size, right? Now, when the kids get a little older, right, they start to move to a standard size Lego block, something like this.
That's my daughter, 4 years old. Yeah.
Okay, start to be accustomed to. Okay, but guess what's ahead for you? I'll tell you something. When they get a little bit older, then my son is 8. He loves to build, really, really loves to build Lego. For his birthday recently, I got him a Technic Lego set. Have you heard of this?
Yes.
Okay.
That's the one I feared when I was 8 years old. Good on your son.
So the Technic Lego sets are far smaller pieces. They have moving models. The one I recently got him is a Lamborghini. So we're building a Lamborghini together. I also love to build. We're building a Lamborghini together. And then you get into pieces that are like this, highly customized, teeny tiny, have to have a lot of precision and dexterity to assemble these. And it also takes a lot longer to put them together. So the analogy I want to use for process node is you can think of a wafer like a giant base Lego plate. Okay, the silicon wafer. And if you have a larger process node, you're dealing with something like a Duplo block, okay? So these pieces are a lot bigger, and for the same, die area, the same, say, small chunk of real estate on the wafer, you're going to be able to put a lot less of those Duplo blocks in, right? Versus something like a standard Lego. And when we're talking about an advanced process node, we start to get into these Technic size pieces, these really teeny tiny, very custom built pieces, right? And so we can pack a lot more of those into the same, portion of the wafer, the same part of the Lego base plate. So this is important not just because we can pack more functionality into the same area, but we can also run that functionality with much lower power and with much higher performance. So to extend my Lego analogy just a little bit more, if you'll humor me.
Of course, yes.
We can think about our wafer base plate, like the base plate of our Legos and what we're trying to build with it. Let's say you're trying to build a city. And you have a certain amount of area that you're building your city in. Now, if you're using the Duplo blocks, you're not going to be able to get as many buildings into your city.
Sure. Yeah.
And not only that, but let's say the lanes that you're going to need to drive between the buildings are going to be much wider. And let's say you have a bylaw too, because of how wide it is and how clunky it is, the speed limit's going to be a lot lower as well. And it's going to take you a lot more fuel to get between different areas of your city. Now, when you can pack, you've got your little pieces now, and you're building a city from these small pieces, you can pack so many more buildings into the same area. And you can make the lanes of your road much more narrow, and that will allow you to get between different portions of your city much faster, so higher performance, and you use less fuel in your car to get between these places, so less energy used. So to kind of recap on the analogy, the more advanced process nodes will allow you to pack way more transistors in, which gives you more functionality, higher compute. And it will allow you to do so with higher performance and lower energy expenditure.
Trust me, Jesse, from today on, a Lego block will never look the same to me again. I always think about this. So we have smaller Lego blocks now in Tensor G5. And as you mentioned, that leads to, better energy, lower heat, and more functionality. So what is it that G5 now makes possible in the Pixel 10 series of smartphones? What can it do that maybe previous generations couldn't do as well?
Yeah, great question. So as I mentioned, the Tensor SoC is the brains of the Pixel phone. So it's running everything on the phone. But some of the use cases, the new use cases on the Pixel 10 series that we're really excited about include many, many more Gemini Nano-driven experiences. So things like Magic Queue, which is an agentic helper, right? Surfacing really relevant suggestions to you throughout the day based on learning about how you like to use your applications. So Magic Queue is one that we're excited about. Voice Translate. Have you got to try the Voice Translate?
It was really, really interesting to hear a friend speak, Spanish, knowing that they absolutely don't speak Spanish in their voice. And then to finally think that maybe a few years ago, I think people would absolutely say this could only work in the cloud maybe. And that's no longer the case.
Exactly. Thanks to the processing that we're able to do locally with Tensor G5 and the latest Gemini Nano model, we have this voice translate feature, which, as you described, not only does live on-device translate in real time, it's doing it in your own voice, like mimicking your voice characteristics. And what we love about this feature is it doesn't require any prior voice enrollment. You don't have to train it, record your voice, have voice sampling out there. It just starts within a few seconds of you beginning to speak. And it also is translating the other direction. So when you're listening to your friend and speaking Spanish, they don't need to have a Pixel phone on the other side. They don't need to have the latest. It's actually translating for you because you've got the processing on your side. So it's really amazing. So voice translate, all on device, another one we're really excited about this year. And then a number of new camera features. Of course, Pixel is very well known for its magnificent camera, not only from a quality perspective, but also all the camera intelligence, the computational photography that we've been known for generations now. A couple features there that are really exciting. ProRes Zoom. So, we talked about that a bit already, but ProRes Zoom is a combination of, on the Pro phones, the new sensors and the increased compute power, that processing power in the Tensor G5 TPU, that's allowing us to extend your zoom range from 30x to an incredible 100x while resolving these intricate details in the image. It's really amazing. And as I mentioned, that's possible because of this co-design we did with the Google imaging research team for this nearly 1 billion parameter diffusion model. Now that's running, since you've tried it out, you'll know, but for those who haven't yet, that diffusion model is running within a few seconds of you pressing the shutter to capture. It's just incredible. And that would not have been possible in that low latency without the Tensor G5. Just would not have been. We would not have been able to do that in the same way as.
Do you remember trying this for the first time? Because it's one of those features that is so linked to the work you do, right? I mean, you don't work in a camera team, but you work in a team that makes their work possible. So what does it feel like trying that for the first time?
It's just incredible. And actually there was two memories I have of this feature earlier on before I even got to try it myself that really stick out in my mind. The first one was, I recall very clearly when the emails went out, or the chat messages, I forget which one. The messages went out around being able to get this down from when we first ported the model and began working on it. It was running over 100 seconds it was taking to resolve this.
Oh, wow.
And through the series of months of optimization and really being able to harness all of the additional horsepower we have in the chip, and fine-tuning the model and optimization, all this side-by-side co-design effort, we land where you see today, where we're within a few seconds being able to run this model and resolve the image. So that's one thing that I remember when we got to that milestone of being within this UX target that we had for ourselves to make this feature actually shippable and usable in hand. I remember very distinctly the congratulations messages going out around getting to that milestone. And the other milestone I remember, the big wow moment for me, was actually when our camera PM, Ashwin, had been on a trip. He went on vacation to New York, and he had brought his Pixel 10 dog food device with him.
Dog food, for the people who don't know, is like we are testing our own devices and software before they go out into the wild. So we're eating our own dog food, right?
Indeed. So he had brought his Pixel 10 sort of early test device with him on his trip. And when he got back, he sent us a picture. He was in the One World Trade Center and taking a picture of the Empire State Building.
Mm-hmm.
So from the top of the One World Trade Center, taking a picture of the top of the Empire State Building and showing the zoom in and the resolution that he was able to achieve with that, and the sharp, like incredibly sharp detail from miles out. And everybody knows what the Empire State Building looks like, right? So if you get it wrong, like people are going to know. This was so sharp and crisp, and it was a big wow moment to see that. So that's an example I still like to use, like in the press briefings I did for Tensor G5 in the last weeks. I use that example because for me that was like a big wow moment of, oh my gosh, it's incredible what we're doing, what we're able to pull off.
So I'm sure in those press briefings, but also elsewhere, we talked about the Tensor team working together with the Google DeepMind team. So talk a little bit about that cooperation. And is that like people from Tensor and people from Google DeepMind sitting in meeting rooms together, coming up with ideas how to make stuff better and faster and more cool? Is that literally what happened?
Yes, exactly as you described. We sit side by side with Google DeepMind researchers, the Tensor team and DeepMind researchers. And this year, we started earlier than ever on the co-design of the latest Gemini Nano model. So for those that are not familiar, Gemini Nano is our sort of smallest model that we use for mobile phones and for embedded platforms. And it's a sister model, really, of the big Gemini models that run on the server that power, the Gemini chatbot or other Gemini-driven features that you would access through the Gemini app or through a web browser interface into Gemini. So we've worked together with them since, we launched the first Gemini Nano model back on Tensor G3 with Pixel 8. But this year, we started earlier than ever. So for over a year ago, we were sitting together, brainstorming ideas. And the way it works is, the Google DeepMind researchers are experts in large language models, like, as I mentioned, the versions that run on the server. And so how to get the highest quality model, that's really their expertise, how to get the very best, like state-of-the-art LLM. And on Tensor's side, our expertise is in design for constrained environments, right? We're mobile semiconductor people. So we're used to constraints around battery life, energy, right? We're used to constraints around memory footprint and the computing power that's possible on the chip. And so sitting together, those two areas of expertise coming together is what really is allowing us to unlock these step changes in innovation on device. And so I'll give you an example. There's a number of co-design innovations that came through this year that you'll see manifesting themselves on the Pixel 10. So just to nerd out for a minute, I know you like to nerd out, Rachid.
Yes, I do.
Okay.
I admit.
Yes. Okay. We'll go there. I know a lot of the people that listen to the podcast probably do too. So we'll nerd out for a minute. Not that the process node wasn't nerdy, but we'll go here. We'll go machine learning nerdy for a moment.
All right,
So
here we go.
one of the co-design innovations that we worked on together with the DeepMind researchers is called a Matformer model. And a Matformer is not named after somebody named Matt. It's actually named after a Matryoshka Russian nesting doll. Do you know these Russian? I'm sure you're familiar
the one
with
that goes over the other. There's one hidden in the other all the time.
Exactly. So you got a little
Right.
doll in the middle, and then a larger one on top of it, a larger one on top of it, larger one on top of it, like that. So we use that same kind of concept for the architecture of the Gemini Nano model. We have a larger full-size model for peak quality. And then we have a smaller submodel that nests inside it for peak speed. And the beauty here is that each application that is leveraging Gemini Nano can dynamically choose between running the full model for peak quality and the submodel for peak speed, depending on the need in the application at that time. But they don't have to manage a different interface between the model. It's all like one programming model.
So you did the co-designing, the co-innovation, the Matryoshka dolls, everything. what does that end up like? What's the benefit for me as a user of the Tensor G5 chip?
Yeah, absolutely. So the Tensor G5 chip, as I mentioned, has all these upgrades for more TPU compute. We've got faster memory interfaces, faster storage, and we're combining that with these optimizations tailor-made in the Gemini Nano model. And so the result of combining those two things is the highest quality model on a phone, highest quality LLM, and it's faster than last year, and it's more efficient. All three, like quality, speed, and efficiency, which is kind of incredible if you think about landing all those things at once. So to give you a very concrete example of how can influence and improve user experience, take a use case like recorder summarization. So we're able to run the model 2.6 times faster and twice as more energy efficient for use cases like recorder, just like in one generation.
So I'm just wondering, you as an industry veteran and working on Tensor, what do you think about benchmarking?
Yeah, so benchmarks give you some information, but they really don't tell the whole story. And my philosophy is we're not designing a chip for benchmarks. We're designing a chip for people. We're designing a chip for Pixel users. That's what we care about. And we're really lucky to be an in-house silicon provider. We can focus our energies on designing for use cases, designing for the best performance, the best efficiency, the best overall end-to-end experience for those use cases that we think Pixel users are going to benefit from. And that's where we focus our efforts. So yes, benchmarks can give you some information. They can be useful as a tool, but they're not the end all be all. They're not what we're designing for. I would also add that I think there's perhaps a misunderstanding there when we say that, like, hey, benchmarks are a piece of information, but they're not the only piece of information. I think some people may misconstrue that as saying that we don't, quote unquote, care about performance, but that's not true. You can see in our upgrade this year with Tensor G5, we have made investments in improving performance in all kinds of ways. For example, as I mentioned before, the TPU has 60% more compute. Now, we're not putting those, we're not packing in those additional transistors, going back to the process node conversation, for nothing. We're putting them there because we know that they will help us unlock that next generation of AI innovation, those next industry-defining experiences, things like ProRes Zoom or things like Magic Q. We can do more because we have that performance available. So it's not that we don't believe in performance. We absolutely do. It's that we put performance for a purpose. We know we're anchored in how are we going to unlock AI innovations? How are we going to improve fundamentals that we know Pixel users care about? That's where we're putting our efforts. That's where we're investing our time and energy. And moreover, I believe that the way the entire industry is defining flagship for a mobile processor is clearly shifting. It's growing. As I mentioned, if we think back to 2021, when we started out in this journey with the Tensor program, and then we see where we are today, the way that everybody is talking at their launch events around what's new, what's improved, where they're focusing their energy, there's clearly been a shift. And I think that Tensor was really ahead of that curve. From the very beginning, we have centered our efforts, our mission around on-device AI innovations. And much of the industry is now, in many ways, playing catch-up with that. And if we zoom out for a moment and we think about the journey we've been on with mobile phones over the last 20, 30 years, I think it's fair to say that we really are at an inflection point right now. We're clearly making a transition. So pre-2007, we had feature phones. Between 2007 and now-ish, right? We've had smartphones. And in the last few years, clearly we're making a transition into a new category, and that's an AI phone. And I feel that Pixel and Tensor have really been at the front of that pack. We made that turn into that inflection point early. And that's really important when it comes to silicon because, Rachid, as you know, our life cycle, from talking with us before, our life cycles are very long. Yep. You have to be leaned in. You have to be making these bets early on to be able to catch these trends as they're coming to light. So I feel really solid about Tensor being a flagship processor for the new AI phone era.
Now, Jesse, I wanted to close our conversation with something really special, and I think people should hopefully are watching this on YouTube, because next to the Lego blocks on the table, I know you have an actual Tensor G5 laying around there. People will probably know what G5 is, but they've never seen it. So this is your chance, and probably people need to come up to the screen fairly closely, because these chips, they're getting smaller and smaller, aren't they?
Absolutely. So this is Tensor G5. I'm going to get a little close to the...
You're doing the creator thing. That's really
nice. The creator
nice.
thing, trying to sell this makeup palette to you. Okay. So it's like, I mean, we're talking about all these, use cases. This thing unlocks all the complexity. It's running nearly 4 billion, or 4 billion effective parameter Gemini Nano model, right? And all of the, many experiences that this chip runs. It's all.
What are we looking at? This is the rear, right?
Yes. So sorry.
The bottom side, I guess.
This is the packaged part. So the chunks of wafer that we talked about earlier, they're inside this package.
Right.
And this is the front or the top of the chip where you have the part marking. And then here on the back, these little, hopefully you can see them, these gold, what we call bumps. These are actually how the chip gets, the silicon rather, gets connected to the phone board. So these are all, I don't know if you can see them, it's very difficult. But these are, hundreds of what we call balls or bumps that are on the back. And this is how the signals get in and out of the packaged chip. And so just to give a size reference really quick, here it is next to a dime. So it's smaller than a dime.
Well, Jesse, congratulations on Tensor G5. I'm sure your head is, so as you mentioned, maybe a few years already into the future, bringing us even more, bringing us even more amazing AI innovations, and can't wait to have you back in a future episode and see what the state of the art is by then. So thank you so much for coming to the podcast.
Thank you, Rachid. It was a pleasure.
Thank you for listening to the Made by Google podcast. Don't miss out on new episodes. Subscribe now wherever you get your podcasts to be the first to listen.